Hello world, Extrapole here. What if I told you that you can implement artificially intelligent algorithms right now in your calculator? Yes, in the same calculator that has been collecting dust in the depths of your drawer since your high school days. Unless you are a high school student, then maybe you have your calculator right in front of you. In that case, just ignore what I said. Wait, do students even use calculator nowadays? Anyways, let us not get sidetracked here. The point of this video is that you don't need a Jarvis installed in your supercomputer to do AI. Many AI algorithms don't even require a computer. One such fundamental algorithm in AI and machine learning is called linear regression. In linear regression, as the name suggests, one assumes a linear relationship between the input and the output. A linear relationship is just a fancy way of saying that it's a straight line. Let me give you an example. It's 2 AM and you have just finished watching 3 Indian guys make a pool in the middle of the forest with their bare hands for the 247th time. As the pool starts filling up, a strange motivation fueled by self-pity and late-night social media-induced stupor starts taking over your mind and body. And all of a sudden you have the urge to get your life back on track. So after cleaning your room, you decide that you will finally start following that fitness routine you bookmarked in your app 4 years ago. The next morning you are a changed person and you start your routine. The routine requires you to do 10 push-ups on the first day and you do them like an absolute champ. As your body gets used to this new regimen, the next day you do one more push-up than the previous day. And then one more, and then one more. And soon enough, within weeks, you have the body of a ripped Greek god capable of doing push-ups endlessly. Now, if we look at the graph of the number of days versus the number of push-ups you could do, it would look something like this. A perfectly straight line. But this is not very realistic, is it? Real-life data is much more complicated than this. Here is probably how this would play out in the real world. On the first day, you managed to do 7 push-ups before you asked your roommate to call the ambulance for you because you thought you had dislocated your shoulder. The second day, you had 3 cups of coffee and were able to complete 12 push-ups. Good job. On the third day, you did only 3 push-ups because you slept for 40 minutes that night. The next day, you did 10 again after getting a good night's sleep, and so on. Now, this is how real-life data looks when plotted on a simple graph. It's not ideal, it's not uniform, and it's noisy, but it still follows certain rules. Now, if we wanted to define this rule, this relationship in your data, as a linear relationship between the number of days and the number of push-ups you can do, how would you do it? How will the straight line look like? Will it look something like this? Wait, that doesn't look right. Maybe something like this. Not that either. Well, this is where linear regression comes in. The linear regression algorithm allows us to find the most appropriate straight line that will give us the relationship between our input, the amount of days we trained, versus the output, the amount of push-ups. Well, let's try it and see how it looks in our case. I think this is the perfect time to bring out Percy, our friendly neighborhood AI. He does all the heavy lifting for me, I just push a button. Percy will now implement the linear regression algorithm on our data. Get to work, Percy. While Percy does his thing, if you are liking this video so far, please like and leave a comment as it helps me out a lot. No pressure though. Alright, looks like Percy is done. Nice. You can see that the line Percy calculated using the linear regression algorithm doesn't go through any single data point, but captures the trend of the entire dataset. Now, there are many types of linear regression, and the one Percy implemented is called ordinary least squared regression. I will not go into the details of the algorithm, but I will leave some relevant links in the description in case you are interested in the maths behind it. Thus, you get an idea about how useful such simple algorithms can be. But you might be thinking, wait a minute, this doesn't seem very AI-y. This is just maths. What's so intelligent about it? Well, that's a very legit question to ask. Linear regression actually comes from the field of statistics, and as I mentioned, doesn't really need any kind of computer processing to implement. You can do it by hand. But the field of artificial intelligence and particularly machine learning has borrowed it because linear regression can be used to make predictions. Let's go back to you doing push-ups. Let's say that by the 7th day you're starting to feel pretty confident about your push-up abilities. And you start to wonder, if I continue on my current trajectory, how many push-ups will I be able to do a week from now? Linear regression allows you to answer this question. Yes, on the given day, you might do 2 more or 3 less, but you can get a good idea about the approximate number of push-ups you would be able to do. This is what AI is all about. Analyzing data to make informed predictions about new data. And this is exactly what linear regression achieves. Now, linear regression is pretty neat, but it has its pitfalls. The primary pitfall is the very nature of the relationship linear regression assumes in the data it is supplied with. Real-world data is often very complicated with lots of factors of variance, and ignoring these factors might often lead to incorrect predictions. Going back to our push-up example, we assume that the number of push-ups we can do should increase over time as our body strength increases, right? Which is true, broadly speaking. But there are so many factors of variance that may influence our performance, like the time of the day, pain or soreness in our muscles, consumption of performance-enhancing drugs, daily calorific intake, the amount of rest we had the previous night, the presence of a friend or a loved one, muscle memory, and so on. Sometimes the relationship between data features might look linear initially, but can be extremely non-linear as new data comes into light. For example, here are the audience scores for the first 4 seasons of Game of Thrones. Based on this data, if you were a naive fan like me in 2014 and wondered what the ratings of the subsequent seasons would be, and used linear regression to predict them, you would get something like this. All 97s and 98s. Oh, my sweet summer chat. We all know how this turned out. Sometimes the data we have is just not suitable for linear regression and one should avoid using it. This is very well explained by Anscombe's quartet, where we have 4 datasets that are identical when statistically examined, but are very different when graphed. The point I'm trying to make is you cannot use linear regression on any given dataset. I mean, technically you can, but you might get very wrong, horribly wrong predictions. Just ask Dan and Dave. And lastly, don't worry, I didn't clickbait you. You can actually perform linear regression using your Casio calculator. I will not teach you how, but I will leave the link to this gentleman's video on how to do it in the description. See you in the next video. Until then, stay artificially intelligent and keep learning. Bye bye.